There are a few things that to keep in mind to better understand the science and chemistry of how the brain works. And so those three things are one, the shape of a molecule determines its function. Two, the energy is shared, released, and stored through the forming and breaking of covalent bonds. And three, the sharing of electrons causes a voltage or a charge to occur. So there were a few concepts that you understood, but there are just some minor details that we need to address. So let's start with the basics. So atoms, they are a part of our existence, such as oxygen, hydrogen, and even carbon, like you mentioned. But carbon itself is the atomic and structural basis of life. These atoms by themselves are neutrally charged. However, when they lose or gain an electron, they do become positively or negatively charged. When this occurs, these atoms are trying to form bonds with other atoms that they can benefit from. The bonding between these atoms causes them to become molecules. Water, for example, is a molecule and is made up of two hydrogen atoms and one oxygen atom, creating H2O. So you're on the right track, but just a few little things that were a bit confusing. And so you also mentioned the protein bilayer. Um, you kind of got that kind of confused, and so the correct term is the phospholipid bilayer, and it is made up of carbon and oxygen chains, and with the phosphate head. So the protein bilayer membrane of a nerve cells are studded with protein molecules that allow for ions to move in and out of the cell. And so the phospholipid bilayer is a lipid, which means that it is a fat, so it's hydrophobic, and ions that are trying to pass through are hydrophilic. And so, in order for them to pass through, they need a protein. These proteins um, open up channels and close them in order for ions to pass in and out. And so, ions or these charged particles tend to move down this gradient from high concentration to low concentration. And so you ask, like, how does thinking work? And so pretty much the brain is made up of thousands of these nerve cells in the brain, and the communication between these cells allow thinking to occur. So various channels. The most important would be the sodium potassium pump of a nerve cell, because it pumps sodium out of the cell and pumps in potassium. And because of this, there is a charge difference and a gradient difference, which is and that movement of those ions is how electricity is, and that's pretty much the communication that goes on in the brain. And so to just understand the nerve cell, they pretty much are at rest at their resting potential. It is at negative 65 millivolts, and so there when a signal is passed, there's a depolarization, meaning that the inside and the outside are closely together, so it becomes negative 50 millivolts. And so that tells voltage gated sodium channels to open up, and sodium flows into the cell, making it more positive until it reaches a positive 30 millivolts, and then the sodium gated channels closes. At that time, the inside of the cell is more positive, and so the gated channels of potassium opens, and potassium flows out to reach back at the resting potential membrane, but it reaches at negative 70 millivolts. And in order to get it back to that negative 65 millivolts that it wants to be, the potassium sodium pump works to push out 3 sodiums and push in 2 potassiums to reestablish that inside outside difference. And pretty much this goes all the way down through the axon, through the cell's axon, and when it gets at the end of the axon, it reaches the axon terminal, and the synaptic vesicles have sacks of hundreds of neurotransmitters, and these neurotransmitters are released and to the post cell. And this is pretty much what thinking is in the forebrain, where higher functioning happens. And so pretty much thinking is the electrochemical communication that occurs in the brain. So I hope that helps. Thank you.